Here are two derivatives to try on your own, but let's try them one part at a time. So for part A, we have the derivative d by dx of x to the power of negative natural log x. So you can use logarithmic differentiation here. That's what I'll use. You can also use the stacking method if that's more your style. But one way or the other, pause the video, work on this first one, and then we'll work it together and make sure we're getting the same thing. Okay, well, anytime you have an x in the base and in the exponent, that tells you you're going to need some kind of special differentiation. I prefer logarithmic differentiation. But the crucial step is recognizing that there's an x in the base and in the exponent, thus we have to do something special. Okay, so I'll write this as y equals x to the negative natural log x, and then I'll, of course, take the natural log of both sides, which brings this negative natural log x down to the front. So we have natural log y equals negative natural log x times natural log x. Let's go ahead and take the derivative of both sides now. So I'll write a d by dx on both of those. I have this weird negative hanging out here on the right, but that's okay. The derivative of natural log y is 1 over y, and don't forget your y prime, that's the chain rule. And on the right, we'll need to use the product rule. I'm going to treat negative natural log x here as my a, and natural log x again. The second natural log x is b. Then recall that the product rule is a prime b plus b prime a. So we have a prime, so how about negative 1 over x, natural log x, a prime b, plus b prime, 1 over x times a, negative natural log x. So that tells us that 1 over y prime is simply, we can combine these to get negative 2 natural log x all over x. Okay, next we bring up this y to the other side. I'm actually going to bring it up to the right side here because it's nice to have this negative 2 out in the front. So this gives us y prime, which is what we're looking for. That's our final answer there, equals negative 2 natural log x times x to the negative natural log x all over x. There we go. Okay, well, hopefully that's what you got when you worked through this problem. If not, make sure you know kind of where you went awry. Part B asks us to find the derivative, d by dx, of sine of the quantity x to the 5 cos x. So a lot going on there. Pause the video, work through part B, and then we'll work it together and see what we get. Okay, well, the chain rule tells us that when we take the derivative of sine of anything, we start with just the derivative of the outside, cosine. The inside stays the same. That's just the chain rule, x to the 5 cos x, times the derivative of the inside. Well, that's not a trivial thing. So I'm just going to write x to the 5 cos x prime. So let's just look at this derivative, right? This thing here, x to the 5x cos x. So I'm going to write this. So I'm going to use logarithmic differentiation again here. Y equals x to the 5 cos x. All right. Take the natural log both sides, of course. Down comes this exponent, so that gives us natural log of y equals 5 cos x natural log x. Now we're ready to hit both sides with the derivative, d by dx of both sides. Of course, on the left we get 1 over y prime. And on the right, we have the product rule here. So I'm going to treat the 5 cos x as a and natural log x as b. Then, of course, the product rule tells us that that derivative is a prime b plus b prime a. So we have a prime b, that's 5 derivative, so make that negative 5 sine x, since the derivative of cos is negative sine, b, natural log x, plus b prime, 1 over x, times a. So I'm just going to write this. So a is 5 cos x over x. There's my b prime. So b prime a. And finally, multiplying up by our original y, which we call that our y was x to the 5 cos x. So now we're multiplying up by that. I'm also going to factor out a 5 out of this thing here. clear out some room. We're going to need it. So factoring out a 5 and bringing up this original y here tells us that our y prime is 5 times x to the 5 cos x times, how about we write this as cos x over x minus sine x natural log x. It's a good way of writing that. But remember, all of this was just this prime bit right here, x to the 5 cos x prime. So then our final answer is cos x to the 5 cos x, right, times all that stuff I just circled. Well, I'm going to bring this 5 out to the front. So then we have 5 times cos x to the 5 cos x times x to the 5 cos x. How about that? Times all this other stuff. Cos x over x minus sine x natural log x. That was a non-trivial derivative.